Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Picard. And we're going to go over natural logs today. But before we get into that, we'll review using the log base button on your calculator a little bit here. So we're going to use logarithms to solve this because 3 to the x equals 19. I could never get 19 down to a base of exactly 3. It's not like 3 squared or 3 cubed or something like that. So we're going to write it as a logarithm. My base is 3 and my exponent is x in this case. And those are the two things. So it's log base, so we'll do subscript of 3 of 19 equals, it's always equal to your exponent, and that's x. So now we just plug it into Desmos over here. So what do we got? Hit the function button, go down to miscellaneous, and then their log base A, that's your log base button. So type in your 3 for your base, and then 19. And you got your answer. X equals 2.6801. And we're good to go. So let's do the next problem. This one's a little bit more complex, but it's basically the same thing. Now, the main thing is you got to get your base, which is 6 by itself, and your exponent in this case is x minus 4. So if I can get 6 to the x minus 4 all by itself, then I can put it in the right as logarithmic equation. So first we're going to add 4 to both sides. 2 times 6 in parentheses x minus 4 equals 42. Now, a lot of people want to multiply these two, but 2 is not to the x minus 4 power, so I can't multiply the 2 and the 6 in this case. So we do have to divide by 2 here and to cancel that 2 out, and I get 6 to the x minus 4 power equals 21. Now I can put it in log base, and remember, this is your exponent right here. So when I write this, it's log subscript or base 6 of 21 equals that x minus 4. So using Desmos again, I'm going to type in that log base button. So hit function, miscellaneous, and then there it is, log base A. That's my log base button. Hit 6 first for your base. You can arrow over a couple times and type in 21. So we're going to get this, 1.6991 equals x minus 4. And then to solve this, you would just add 4 to both sides once you're to that point. So x equals 5.6991. And that's kind of what we covered previously, okay? So now we're going to get into natural logarithms, okay? And that's just with a base of e right here. We talked about common logs. And the common log has a base of 10, and that's just log. So I know the log button on my calculator is log base 10. E is actually a number like pi. Like pi is 3.14159. It kind of keeps going forever. E is a natural occurring number. They call it the natural number because this number occurs a lot in nature. It's actually 2.7182, and it just keeps on going. So they have a natural logarithm because we use E a lot in some of these formulas, and in order to solve some of these exponential equations that contain E, we need to use the natural log. So what we need is log base E. Well, that's the same thing as ln. Whenever you see an ln, that's a natural log with base E. so a couple ways to write this. It'd be log base e of 5 equals your exponent, which is 2x. But we're not going to use log base e. Well, we are going to use log base e, but we're going to use the form for it, which is ln of 5 equals 2x. This is how you write log base e. Use the ln. Okay, so let's go up here. Get rid of this for a little bit. Okay, oops. Works pretty easy. First thing we notice, a couple things. E is my base, and x is my exponent. Anyway, instead of log base e, I'm just going to use the ln, because that is log base e. Of 3, we're going to put that in parentheses always, and then it's equal to our exponent, and our exponent in this case is x. So going backwards, well, ln means log base e, so it's e to some exponent. Well, here's my exponent. It's 3x minus 1 equals the 14. So we can go back and forth with this ln. For this one, 4x plus 5 is your exponent. E is my base right there, so I'm going to use the ln. ln of 10 equals my exponent, which is 4x plus 5. And we'll solve some of these in a minute. This one, why don't you try these next 3? Hit pause, try them, and then unpause it, and then you can check your answer. So hit pause now. Okay, you probably have done it already. So ln for e, because we're using e, of the x minus 2 equals the exponent, and the exponent in this case is 13. Here's my exponent, 7 for this one. It's base e, so e to the 7th equals x plus 4. Here's my exponent, so it's going to be e to the 6x equals 5. So kind of going back and forth there with these natural logarithms and the e, that natural occurring number 2.7812. So we're going to solve this equation using natural logarithms. Now, the deal is I got to get the base by itself. So that e, which is my base, I have to get by itself, and the 5x is my exponent. And we're going to set it equal to the exponent in a minute. But first, I got to get rid of the 2. I can't multiply the 2 and the e because e is raised to the 5x power. So really what I'm going to do here is get rid of that 2 first. And now I get e to the 5x equals 10. Now I can write it as a natural logarithm. Log base e is actually the natural logarithm, ln, of 10. Now put that in parentheses. It's going to make a big difference. Equals my exponent 5x. Okay? So now we can actually solve. We're going to divide both sides by 5. And x equals whatever this is. So we're going to plug that into our calculator. Pull this out over here. Just be careful with the parentheses. Go to function, and now you want that natural log. Now it's in the first column here. It's the 1, 2, 3, 4 down. ln. It's lowercase ln. I'm just going to hit that. There it is, ln of 10. Finish off parentheses. Okay, and then we divide by 5 in this case. So we're going to divide by 5, and there's our answer. X, oops, get my marker, x equals, what is it? 0.46, 0.05. And we're done. It's that simple. Okay? It's almost easier than the previous logarithms. So let's go over here. And let's do this one. Okay? Well, e is already by itself. So we're going to go log base e, which is the ln of 15. It's always equal to the exponent. There's your exponent right there, 2x plus 3. So here's what I would probably do with this one, just to make it a little bit easier. Before I start solving for x, I'm going to find out the ln of 15. So I'm going to go to function ln 15. That's 2.7081, we'll say, if you round it, equals 2x plus 3, and then just solve. Okay, once we do that logarithmic function, the natural log function, get to the ln of 15, which is that decimal. I'm going to subtract 3 from both sides. Okay, so we got 2.7808, minus 3. It's going to be a funky number, negative 0.2919 equals 2x. And then finally, to solve this, we're just going to divide by 2. So it's going to be a small negative decimal, and that's fine. Negative, what is it, 0.2919 divided by 2. There we go. And that's how we do it. If you see E, you're going to use the natural log in order to solve that bad boy. And that's pretty much it. I think I'll try one more over here. Now, this word problem number 9, it kind of goes through it and it sets it up for you right here. Now, the E's on the right-hand side, so you can flip-flop that and put E to the negative 0.1625t equals actually 0.5, and then do your logarithm if that makes a little bit more sense for you. That's fine, but here's your word problem, and they set the equation up for you. We're going to work on that next week, you guys setting up the equation. How about, let's do a tough one. Let's do 4 here. You guys should maybe try 4 first. Hit pause, and then I'll go over it with you. Okay, my base is E, so I got to get that by itself. So I'm going to add 9 to both sides. I get 3.4 E. The 2 minus 2x, kind of funky, but equals 27.2. I can't multiply 3.4 times E, so I'm going to divide both sides by 3.4. What do we got? 27.2 divided by 3.4. There we go. It's 8. So we got E to the 2x. Oops, that's wrong. E to the 2 minus 2x equals 8. Okay, so now we're going to write this as a logarithm. Log base E of 8 equals my exponent. Well, if it's log base E, that's when we use the natural log of 8 equals 2 minus 2x. So I'd find the natural log of 8 first. Just get that decimal and then work with that. What was it? 2.0794. Okay, so it's 2.0794, and that's equal to 2 minus 2x. And then just solve this equation. First thing we're going to do, obviously, is subtract 2 from both sides. And I'm going to get 0.0794. That's the decimal right there. Equals negative 2x. And then just divide both sides by negative 2. X equals, okay, what do we got? 0.0794 divided by the negative 2. So negative, first of all, 0.0397. Kind of a funky little negative decimal, but that's it. Go ahead and finish this up, submit it, and we'll see you next week.